Hello students, we're going to begin Chapter 8, Polynomials. Before we talk about polynomials, let's talk about what a monomial is. You've been dealing with monomials when you have been multiplying exponents. A monomial is a real number, like the number 18, a variable, like the letter z, or the product of a real number and a variable, like negative 4x squared is negative 4 times x squared. What you notice is that it's connected by multiplication. It's 2.5 times x to the fourth times y. As long as they're connected by multiplication, it's a monomial. We classify monomials by their degree. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant, like 18, is 0. And the number 0 itself has no degree. So the three numbers below here are monomials. Okay, a number times a variable, or a number times more than one variable. Each of them are monomials. Let's find their degree. So since the degree is equal to the sum of the exponents of the variables, you would agree that the degree of 5x is 1, because 5x is equal to 5x to the first power, and since the sum of all the variable exponents is just 1, then 1 is the degree. The degree of 6x to the third y to the second would be degree 5, because the exponents here are 3 and 2, and 3 plus 2 is equal to 5. And 4 is a constant, and it's a non-zero constant, so we know that all non-zero constants have a degree of 0. Okay, so that is everything you need to know about finding the degree of a monomial. Let's see if you can find the degree of each of these monomials, number 1, 2, and 3. Pause a moment and figure that out, and come back and I'll tell you what they are. Okay, hopefully you paused. Number 1, 8, x to the first, y to the first. The degree would be 2. The degree of the next monomial, y to the fourth, and this is z to the first, would be 5. And the degree of 11, of course, is 0. Okay, let's talk about what you're going to do with these monomials. So far we've been working with multiplications. We are now going to add or subtract monomials just like we add and subtract like terms. Okay, so remember, what is a like term? A like term are terms with exactly the same variable factors. Okay, for instance, 3x and 4x both have x as a variable. You can combine them and that equals 7x. Okay, if they were 3x squared and 4x squared, you can also combine them to be 7x squared. But you cannot combine 3x plus 4x squared. They do not combine. They just stay the way they are. So let's look at these examples. 3x squared plus 5x squared, when we combine like terms, we just combine the numbers in front of the variable terms that are alike, and that would be 8x squared altogether. 4x cubed y minus 1x cubed y is equal to 3x cubed y. Okay? See if you can combine the like terms. What is the sum? In other words, add these two monomials together and then add these two monomials together. What you'll notice is that in both cases the variable factors are exactly the same. This is x to the fourth and this is x to the fourth. And over in this one, we have x squared y to the fourth and x squared y to the fourth. So all you need to do is to combine the coefficients. So you can combine negative 6 plus 11 and get a positive 5. And that's how much x to the fourth you have. And here, since you're subtracting, it's like you're saying 2 minus 7 of this particular variable group or monomial. So it's 2 minus 7x squared y to the fourth, which would make it a negative 5x squared y to the fourth. Okay, so that's how we add and subtract monomials. Again, when we're doing these tutorials, feel free to stop, pause, go back and listen. Polynomial, here's that word. The word poly means many. And in this case, polynomials just means one or more monomials. So the definition is a polynomial is a monomial or the sum of monomials. The following polynomial is the sum of the monomials 3x to the fourth, 5x squared, minus 7x, and 1. Notice how these are all different variable factors, so we can't combine them. So we just have to list them as one expression that contains 1, 2, 3, 4 different monomials, each monomial having its own degree based on its variable factors. So the degree of each monomial is shown. When you write a polynomial, you need to write it so that the degrees of the polynomial decrease from left to right. So when you write out a polynomial containing these monomials, 3x to the fourth, 5x squared, 7x, and 1, you need to write it so that you're writing it in decreasing order of degrees. And that's why we bother to know what the degrees are. The degree of a polynomial. So now we're talking about this whole thing when we put it together. The degree of the polynomial in one variable, meaning just an x, not an x and a y, is the same as the degree of the monomial with the highest exponent. So the degree of this whole polynomial, 3x to the fourth plus 5x squared minus 7x plus 1, is whatever the highest degree of the monomial that is contained within it. So it would be 4. We name these polynomials based on their degrees. We can also name the polynomials based on the number of monomials they have. And if you think about some of the words you know that mean numbers, you know the word mono means one, okay? Poly means one or more. Bi means two. Tri means 3. And you'll be using these prefixes when we're naming with the number of terms. That would be this way, okay? So let's look at how we name the polynomial 6. Now, we know the polynomial 6 is also a constant with a degree 0. It has one term, so it's a monomial. Okay, the next one, 5x plus 9. 5x plus 9 is a degree 1 because the x has only a exponent of 1, so the degree is 1. Anything that has an exponent less than 2 is linear. It has 2 terms, so it's called a binomial. Okay, the next one has a degree of, you guessed it, 2. If it has a degree of 2 or it has a square, it's called quadratic. The number of terms is 3, so it's called a trinomial. 2x to the third power, what do you think the degree is? The degree is 3. Since it has a degree of 3, it's called cubic. The number of terms is 1, so it's monomial. And the last one, 8x to the fourth minus 2x to the third plus 3x, has a degree of 4. Anything greater than 3 is called a fourth degree polynomial with 3 terms, so it's called a trinomial. Now guess what? You can combine these names, okay? For instance, this one, 5x plus 9, is called a linear binomial. 4x squared plus 7x plus 3 is a quadratic trinomial. 2x to the third is a cubic monomial. And 8x to the fourth minus 2x cubed plus 3x is a fourth degree trinomial. Okay, look at these terms and let's classify them. Here are two examples for you. 3x plus 4x squared. First of all, we need to place them in standard form, which means decreasing order with the exponents decreasing. So as we have here, 4x squared plus 3x would be the right way to write this. And since it has an x squared, it's a quadratic polynomial. And since there are two terms, it's a quadratic binomial. Okay, here we have this long polynomial has four terms, and we need to put it in standard form, so we need to write the 5x to the third plus 4x plus 7x minus 1, and it looks like we can combine the 4x plus 7x, so it's going to be 5x to the third plus 11x minus 1, and since the highest degree is 3, it has a degree of 3, and it is a cubic trinomial, and it's called a trinomial because it has three terms. Write this one, 2x minus 3 plus 8x squared, in standard form and give it a name. Pause and come back. Okay, we're back. If you wrote it in standard form, you should have written 8x squared plus 2x minus 3. And since it has its highest exponent is 2, it has a degree of 2, and it is known as a quadratic polynomial. And since it has three terms, or three monomials, it is called a quadratic, you guessed it, trinomial. Alrighty, what I'd like you to do is do all of the problems. Find the degree of each monomial in 8 through 15. Simplify in 16 through 23, and that's just combining like terms, and write them down here. Okay, don't try to squeeze them in here. And finally, write each of these in standard form and give it a name. You can also write them in the big white space that you have here on this paper. Okay, if you have any questions, I'll be around to answer. Work well.